Situational Problem Involving Ellipse by Dave Harvey Moica. Good morning everyone. For today's video, I will teach you on how to solve a situational problem involving ellipse. But before that, let's recall some few terms about different part of the ellipse and what is ellipse. An ellipse is a set of points in plane such that the sum of the distance from each point to two fixed points is constant. Focus each of the two fixed points. Vertices is the line containing the foci intersect the ellipse at points. Major axis, the line segment between the vertices and its midpoint is the center of the ellipse. Covertices, a line perpendicular to the major axis through the center intersects the ellipse at points. Minor axis, the line segment between the covertices. And now let's go to the problem and solve it.
The orbit of Saturn around the Sun can be modeled by an ellipse, with the Sun at one of the foci. The Sun is approximately 231 million kilometers from the center of the ellipse. At its closest, Saturn is approximately 1,269 million kilometers from the Sun. The minimum distance of Saturn to the center of the ellipse is approximately 1,444 million kilometers. Write an equation for this model and sketch to graph the equation. The first step we will do is to remember the equation of the ellipse, and that is x squared over a squared plus y squared over b squared equals to 1. Second step, we need to find the value of a and b and c. To find the value of a squared equals the kilometer of Sun from the center of the ellipse plus the kilometer of Saturn from the Sun. 231 million kilometers plus 1,269 million kilometers equals to 1,600 million kilometers. So our a squared equals to 1,600 million kilometers. To find the value of b squared equals the minimum distance of Saturn to the center of the ellipse, and that is 1,444 million kilometers. Therefore, an equation that models the orbital path of Saturn is x squared over 1,600 plus y squared over 1,444 equals to 1. Since 1,600 is our a squared and 1,444 is our b squared, we need to square it. So x squared to 1,600 plus y squared squared of 144 equals to 1. We squared it to find the value of a and b. X squared over 40 plus y squared over 38 equals to 1. And now we have the value of a and b. A equals to 40 and b equals to 38. A equals to 40 because that's the largest number for the denominator. To find the value of c, we just minus the a squared minus b squared equals 1,600 minus 1,444 is equals to 156. Since it is c squared, we need to square it in. The square root of 156 is 2 square root of 39. In decimal, it's 12.49. So our c is 12.49. And now we have the value of a and b and c. We can now find the major axis, center, vertices, covertices, foci, endpoints of lateral recta, length of major axis, length of minor axis, directrices, centricity, and length of lateral recta. To find the value of major axis, look on the denominator x squared and y squared. The largest number of denominator is 40, so that is in x squared. So that the major axis is in x-axis. To find the center, the formula for the center is h and k. Since there is no number before the variable in the numerator, the center will be 0 and 0. To find the vertices, the formula on the vertices is a and 0 and negative a and 0. Since our a is equals to 40, our vertices is 40 and 0 and negative 40 and 0. To find the covertices, the formula for the covertices is 0 and b and 0 and negative v. Since our b is equals to 38, our covertices is 0 and 38 and 0 and negative 38. To find the foci, the formula for the foci is c and 0 and negative c and 0. Since our c equals to 12.49, our foci is 12.49 and 0 and negative 12.49 and 0. To find the endpoints of lateral rectum, the formula is c and positive b squared over a, negative c and positive b squared over a, c and negative b squared over a, negative c and negative b squared over a. Since c equals to 12.49 and b squared of a equals 36.1, to get a 36.1, 1444 divided 40 equals 36.1. So our endpoints of lateral recta is 12.49 and 36.1, negative 12.49, 36.1, 12.49, negative 36.1, negative 12.49, negative 36.1. To find the directrices, the formula for the directrices is a squared over c. Since a equals to 40 and c equals to 12.49, 40 squared over 12.49 equals to 1600 over 12.49. If we simplify this, we can get 128.102 for a. So our directress is 128.10. To find the eccentricity, the formula for the eccentricity is c over a. Since c equals to 40 and a equals to 12.49, 12.49 divided 40 equals to 0.31. So our eccentricity is 0.31. To find the length of major axis, the formula for the length of major axis is 2a. Since a equals to 40, 2 times 40 equals to 80, so our length of major axis equals to 80 units. To find the length of major axis, the formula for the length of minor axis is 2b. Since b equals to 38, 2 times 38 equals to 76, so our length of minor axis equals to 76 units. To find the length of lattice rectum, the formula for the lattice rectum is 2b squared over a. Since b equals to 38 and a equals to 40, 2 times 38 squared over 40 equals to 2 times 1444 divided 40. If we simplify this, we can get 2 times 36.1 is equals to 72.2. So our length of lattice rectum equals to 72.2 units. And that's how we solve situational problem involving ellipse. And now, let's recall all of our answers. Our standard equation of this problem is x squared over 40 plus y squared over 38 equals to 1. H squared equals to 1600, b squared equals to 1400, c squared equals to 156, a equals to positive and negative 40, b equals to positive negative 38, c equals to positive and negative 12.49. Major axis is an x-axis, center 0 and 0, vertices 40 and 0, negative 40 and 0, co-vertices 0, 38, 0 and negative 38, foci 12.49, 0, negative 12.49, 0, endpoints of lateral recta 12.49, 36.1, negative 12.49, 36.1, 12.49, negative 36.1, negative 12.49, negative 36.1. Directrices 128.10, eccentricity 0.31, length of lattice rectum 72.2 units, length of major axis 80 units, length of minor axis 76 units. And now we have all of the answers. We're gonna sketch it in the graph. Here's our center. Here's our vertices, our co-vertices, our foci, our endpoints of lateral recta, and directrices. Reflection and realization. The feeling that I felt when I'm solving this problem are a mix of emotion. My emotion is changing based on the every step of the problem that I need to be solved, because the more fraction and decimal that I see, I get nervous about my answers, and that is the wrong attitude or behavior that I do. We should always believe and be confident in our answers. As long as the answers you've got is the same on the formula, continually solve the problem. And don't give up. There is hope and wisdom in every problem we're gonna solve. Just focus, remember the formula, analyze the problem, and lastly, don't give up.